Hello, my name is Shruti Anilva Sugde and my PRN is 2305001. Today I am representing the ISE of signal processing on the topic of LTI, that is linear time invariant system. So first of all, I would like to tell some meaning about LTI system. Linear time invariant system means what the system behaves like linearity properties like scaling, addition, etc. And time invariant means what the output of that system does not depend on the time or does not change over the time. So this is all about the LTI system. If we want to give one example about the LTI system, it's like RC circuit, that is resistor capacitor circuit. Then we will see one MATLAB code through which we can plot the graph of the LTI system and see the output. So first of all, we will see, then clear all, close all the windows. So now just we will see this code by using the convolution property. So we will define two variables. That is, first one is the x. That x means take some value randomly, 1, 2, 3, 4. Now for the impulse response, we will give the h value. It will be 1 sum of -1 and 2. Then next we have to plot the convolution. So this command, that is y is equals to convolution of x comma h, we have called. Then next one is what we have to subplot this graph. So we will plot this graph according, but before plotting the graph we will display all these output that calculated x of n and h of n in the numerical form, not in the graphical representation. So for that we will run the command, that is the display of the output y of n, and next display of y. So that function we have called. Next, we will only subplot the graphs according it will plot in that particular position we are giving at 3, 1, that it will select column and row, in which column and row it will be going to plot. So to plot, we will first run the main command, that is stem of x. It will plot the whatever the input we have given to x. According to that, it will plot the graph for the x, and we will use title for this. So the title of this is input x of n. So similarly for that, we will do for y of n and h of n. So we will just change the position, that it will be plotted in second row, and this will be the h of n. H of n is input, but it properly we can say that it will be the step response, sorry, impulse response of that system. And next one is about, so this will be changed, that is stem of h. And now we will plot same for the y. Then we will change the row number, that it will be 3. Here stem of y, it will plot the whatever the output of y we have calculated through the command y is equals to convolution of x comma h. Then it will be plot the output. So what's it output in a numerical form, that is x of n into h of n. So we will plot this graph, we have given the title. We will run this code and see the output. It will take some time. So the output, okay, we will stop the recording. It will take some time. Yeah, this will be our output. We can see that there these two values will whatever the output of all these x of n and h of n, this will be calculated here and plot throughout this graph. So this is all about the LTI system. So thank you.
Now we will see the linearity property of LTI system. Now we will see the step by step code of the LTI system. So our first command is CLC. semicolon, clear, semicolon, and close all. Here CLC is clears the command window text, and for clear removes variables from a workspace to old variables. It does not interfere, and clear all is closes any open figure windows. So next step is our x1 equal to in square bracket of 1 2 3 semicolon, x2 equal to in square bracket of 2 1 0 semicolon, and h equal to in square bracket of 1 1. Now here we will see the meaning of x1 and x2. x1 and x2, it defines the two input signals as 1 by 3 row vectors, and where the h defines the system input impulse response as 1 1. It is nothing but a simple 2 tap FIR filter. Now we will see our next command, which is nothing but the a equal to 2 semicolon b equal to 3. Here a equal to 2 and b equal to 3 is a scalar coefficient. It is used to form the linear combination of a x1 plus b x2. Okay, now we will see the next our command, y1 equal to convolution of x1 comma h semicolon, y2 equal to convolution of x2 comma h. Here the convolution of x1 comma h, it computes the discrete convolution of x1 with h for finite length sequences of length 3 and 2. The result which is the result length is 3 plus 2 minus 1, which is nothing but the 4. Okay, now we will calculate the LHS. Here LHS equal to a into y1 plus b into y2. Here we are computing the a into y1 plus b into y2. This is the left hand side of the linearity test, which is apply the system to x1 and x2 individually, then combine outputs. Now we will see our RHS term. We will type here variable RHS equal to convolution of a into x1 plus b into x2. Here we are typing the RHS equal to convolution of a into x1 plus b into x2 comma h semicolon. It computes the right hand side first from the linear combination a into x1 plus b into x2, which is nothing but the vector scalar, and add it, then pass the result through the system via convolution. Now we will see our next command is display. We will type display disp of LHS of a into y1 plus b into y2, b into y2, bracket complete, colon, then semicolon, and here we are displaying the value of display LHS. Okay, here the display LHS is command is used for the display the value of LHS. Now same we will display the value of RHS. Here display RHS using display command, we are printing the RHS value. It print both arrays so you can observe whether they match. It will if the RHS equal to LHS, then we will see that the system is linear, and if the RHS is not equal to LHS, then we will say that the system is non-linear. So that it is all about the LTI system. Thank you.
Hello, I'm Shraddha Basugde. I am going to deliver the ISE on the topic of ISE of the signal processing on the topic of linear time invariant system. My PRN is 238020. So first we clear the window, then we define the two inputs, that is x is equals to 1 and h is equals to minus 2 1. X is the input signal and h is the input signal system of the system's output impulse response. So again we shift the input time, shifted the input. So we are going to deliver the k is equals to 2, that is number of the samples we are going to shift. So that's why we are using the command like x shifted. So for the output, we are going to use the define the two outputs, that is y1 and y2. Y1 is the output of the systems of original input of x. So we are using the command of convolution x comma h, and for the y2 we are going to use convolution x of the shifted the original signal comma h. So for the y2 is the output of the system for time shifted output, that is x of the shifted. For final output, we are going to define the y1 shifted. So let's check the run and let's see the output. Okay. So for the display function, we are going to use this display commands. Here we can check that see that our output is shifted by the two values. So this is the output. Impulse and step response of LTI system. Impulse response is the output of LTI system when input is unit impulse signal, that is delta of t. Step response is the output of LTI system when input is unit step signal, that is u of n. The code for plotting impulse and step response of LTI system is, first we clear the command window using commands clc clear and close all. Then we define an example of transfer function, that is h of z is equal to 1 plus 2 z raised to minus 1 divided by 1 minus 0.5 z raised to minus 1. The coefficients of numerator are 1 and 2, and coefficients of denominator are 1 and minus 0.5. Here we display our transfer function using command display. Tf numerator denominator minus 1. Minus 1 is used to tell that we used discrete function. If we run this, we got our transfer function. For plotting impulse response, we use following commands: figure, impz. This is inbuilt command in MATLAB to plot impulse response of system. Title, title of figure, impulse response of LTI system. X label, that is x axis we put n.
Y label. In y-axis, we put amplitude. If we run this, we got graph of impulse response of LTI system. For step response of LTI system, we use step Z command to plot step response of system. Step response of LTI system. X label. Y label. Amplitude. Here we got step response of LTI system in x-axis n and in y-axis amplitude. Impulse response of LTI system reacts single instant input, and step response of LTI system shows behavior of input which switches from 0 to 1. This is our transfer function, and this is impulse response of LTI system, and this is step response of LTI system.